All right, guys, we'll try and keep it quick because it's the last talk of the day. So we're students of computer security, so it's going to be a little bit different than what you've been hearing all day, but it's both of our first talks, so I apologize if we stumble or anything like that. These three figures right here, if anybody can guess what they are, they're the costs of data breaches last year by major companies. So Target got hacked, Home Depot got hacked, and Sony got hacked. The idea of this talk is try and help people realize ways to use Python in their business, simple scripts, because the cost of security is expensive. So these companies do risk analysis reports and decide that, well, it's going to be cheaper for me to take the risk and get hacked than it is to actually spend the money and secure our networks properly. So we came up with a few scripts, just a couple simple ideas that you could use in your company to help secure your business, since Python's free. Like I said, my name's Ryan. I'm majoring in information assurance and security engineering at DePaul. I have a network security focus. I was the former president of our security club, and we've been pretty successful. We've done decently in a couple national competitions.
Okay. I'm Li-Wey. I'm also majoring in information assurance and security engineering with a minor in computer science. Besides a networking security focus, I have a application security focus. Same with Ryan. I took part in National Collegiate Cyber Defense Competition, and I also took part in U of I's Hack Illinois.
All right, so our inspiration for this was the aforementioned CCDC competition. So what is this? This is basically a game that University of Texas, or is it Texas A&M? I think it was Texas A&M, invented about 10 years ago. Basically, the idea is red versus blue teams. And if you don't know what that is, a red team are basically hackers, but they get paid to do so. And blue teams are the defenders, so sysadmins and people at your company, and even you guys trying to write secure code, right? So our goal is we go in as a blue team, and we have to defend our network from the attackers. And they score us on this. We have a web server, and if we keep our web server running, we get points. If it goes down, they hack us, we lose points. Pretty simple. So the positives of this type of competition, it promotes team building. There's 8 of us on a team. We go in. We probably practice for about 6 months, so we get to know each other very well, our strengths, our weaknesses. It forces us to do research as students. So we have to go out. We have to learn the systems. We have to, figure out different creative ways to, stop the attackers. They come up with new stuff every year, and we have to come up with new stuff every year as well. It also promotes knowledge transfer. So every year, we're going to have new people on the team. So, as Li-Wey and I become higher up and we leave, we have to train new people to come in and take our place. Now, there are negatives of this type of game. It is a competition after all, and like I said, the team with the most points wins. So really, there's very little sharing in between teams. If I don't want to tell another school our secrets, or else we're not going to win. Well, that's the idea. Today, we want to show our scripts and our ideas and try and switch that around to help kind of promote growth and knowledge transfer there.
All right, so I'm going to start going over some basically example red team scripts. So if I was a red team member, what kind of scripts would I be developing to attack blue team? What I'll be presenting or showing you is webreplicate.py, which will be a man-in-the-middle sort of attack, if you want to go.
Yeah. So if you don't know what man-in-the-middle attack is, it's basically, say I'm a user and I'm trying to get to XYZ's company's website. Maybe it's a bank. So you have all your security in place, but say Li-Wey is an attacker. He's going to get in the middle of that authentication, and I'm not going to know the difference. I mean, I'm a stupid user. I'm whatever, going to xyz.com, typing in my credentials, doing money transfer. But all the while, he's just sitting in the middle, sniffing traffic, wouldn't know anything else is going on. He's going to steal those credentials, use it later to then take all my money.
Okay. And so that's what that's not exactly what replicate does, but it will create a fake website for you to trick users into typing in any sort of confidential information. And then WeyShell.py is a piece of malware that I created that while it pretends to be a browser, in the background it will create a web server on your local host that is a shell. So I will show you how those work. Okay.
So these are just pretty simple scripts. I mean, they're not, I mean, true malware authors will make far more complex things. It's just kind of an idea just to get you familiar with what we're talking about.
Okay, so this is web replicate. So I want to replicate, let me take a look. I want to replicate YouTube. Okay, and then
Like
let's,
con.
yeah,
Oh, okay.
okay. And then let's say I want to run it on port 8001. Okay, so now it's replicating YouTube on port 8001. So now I go on my local host. Okay. All right, so now you have YouTube, but this isn't really YouTube. This is fake YouTube. As you can see, it has my local host. I can also click here. Oh, kind of like YouTube. It's not, but as you kind of get the gist of it, it's kind of a fake website to trick users, steal information, stuff like that. So that's just the basic example.
So if we had more systems, it would, you know, if I was the user, it would show up as a different website than actually YouTube.com.
Okay. So now, okay, the next one is WeyShell. So here I have it right now. Looks like Chrome. Okay. So first, I'm going to see if I have port 8000 open. So that's how I developed WeyShell. I have it open up port 8000. Nope, no port 8000. Okay, so now I'm going to run WeyShell thinking that it's a browser. It's going to open Chrome. It's going to trick you. And then now let's see. Oh, now we have a port open. Let's go to that. All right, so right now you see a blank page. If I was a regular user, I stumble upon this, I would think nothing of it. But let's pass it a parameter. So let's do. All right, now I have getting information. I could run any command, any shell commands on my local machine. Okay, so that
Or a remote machine if
yeah,
you
or
had
remote.
somebody run it.
Okay.
All right, now for blue team scripts. So this is what we spend most of our time thinking of. Well, I think of them, and then Li-Wey writes them. So these are defensive tools to prevent different types of malware and different attacks that red team would use to get in systems. So the first one I thought of was backup.py, and this creates a central server that you can put in different IPs of servers across your environment. It'll go out over SSH, take backups, and then you can set it up to periodically take other backups, and then it'll do an integrity check against that. So, you know, if say you're running a web server, public facing, you can have this go out, make backups, do checks against it, and see, okay, well, this page has changed. Why? Or I'm missing this page, or this was added, and you can look into that further.
Yeah, go ahead.
Okay. Next one is procpew. So this resides on end hosts. This basically monitors current running processes. So as Li-Wey showed before with the malware one, yeah, WeyShell. When you run that, it's gonna create a process and install a backdoor on there. So the idea behind procpew would be to prevent that from happening. So it monitors all your running processes on your machine. When you start it, it'll take a snapshot of those. And then you can either create a white or a blacklist based on that. So whitelist, you would put in certain, whitelist would take the entire snapshot and wouldn't allow anything else to run after that. So if you, try to open up Notepad and it wasn't currently running, it wouldn't allow it. It'll just automatically kill it. Or you can do a blacklist approach where you put in certain applications that you only want to run, or you want to block, and it'll allow everything else to run. Whitelist is a little safer, but Like that could break a lot of things if you don't do thorough testing with it. It blacklists. I'm sorry. And then the final one is Waymon. So this does registry monitoring. This is only for Windows. A lot of malware, in order to maintain persistence, will edit a lot of registry keys. So if you reboot the system, it'll automatically reinstall or reactivate the malware. And we put in, a whole list of certain registry keys that malware commonly uses. And there's two modes to this. It's active and passive, similar to Proc Pew Pew. Active will, when it's run, go out there, take a snapshot, look at the keys and their values, and then if it notices any changes, it'll go back and automatically revert it to its original state. And then passive, it won't do it automatically, but it'll pop up that something has changed.
Okay. All right, so now we'll do a demo of Proc Pew Pew and Waymon. Backup, if we have time, we'll go over that one. Okay, so let me first kill this session. All right. Okay. All right. Okay, so this is Proc Pew Pew. So let me explain what each box means. So this top left box over here, that will be the processes. This bottom left box is the services. And then this over here, this right box, is going to be your blacklist. And this is going to act as the bottom box is going to act as your monitoring box and as your whitelist box. So let me first go over the blacklist. So let's say Notepad. Okay, put up Notepad. Shows me that it's running. Okay, I don't want that. Put on my blacklist. Notepad's killed, as you saw in the back. Just deleted it. So now it's off the list. And then if you notice here, it also saw that Notepad was open, so it's monitoring as well. So what that means is I can also do this. So rather than using a blacklist, I can delete that off. I don't want Notepad on the blacklist anymore. Now I could have Notepad. Okay, it's running again. Now I want to use the whitelist. So this will turn into a whitelist. So how it works is it freezes, or it doesn't freeze, but it looks at your current processes, your current services, and it says, okay, all these are already running. These are okay. These are good. So anything on the bottom box that's seen is going to be removed. So it's like I put this on active. Notepad's killed. Okay, so what about Notepad++? Okay, that should be killed as well. Okay, it saw Notepad++, killed it. All right, so now what about WeyShell? So now we're going to run WeyShell. Okay, still opens the browser. Chrome was originally open, so it says, okay, Chrome goes through. Okay, but it caught WeyShell at the bottom here. And then let's take a look if we still have that port open. No, we don't, because it killed WeyShell. Okay, so that's how Proc Pew Pew works. Okay, and now we will go over Waymon. Okay, so Waymon is going to be a little bit more difficult to explain, just because there's a lot going on. But this is what it looks like. So we, like Ryan said, we have a list of registries that we're looking at. And so when I run Waymon, it looks at those registries and it says, okay, these are the ones that I'm going to trust. I'm going to trust these. Okay, so now I'm going to, so right now I'm going to go into registry editor and make a string. I'm going to say test.
This is simulating malware actually changing something in your registry.
World. Okay. All right, so now Waymon sees that something got changed and there's something new that's created in the registries. Right? I don't like that. So let's say that this is malware. I want to revert. Okay. Revert. Okay. All right, reverted it. It's gone. Cool. What I can also do is recreate it. I believe I made it in. Yep. Okay. so now it's back. All right, let's say that was a change that I meant to do. I actually like this. All right, so I'm going to take a snapshot instead. Okay, so now by taking a snapshot, I'm saying I'm trusting this. It's okay. Don't alert me on it. So now it's empty. However, on the right side here, I have my history of snapshots. So say I want to go back that one. So now it's saying, oh, it's alerting me again. But if I did like it, I'll go back to that. Yeah, so I'll go back to the newer snapshot, and it says, okay, it's good. It also detects anything that's missing. So if I was to remove test, it would alert it's missing, or if I was to suddenly change it. So, okay, should alert me on it. Oh, okay, so now it's saying test got changed to hello world. Okay, I could also revert it. The reverting works for any of these sections, or I could just remove this. I want to delete that. Now it's in missing. So that's how Waymon works. Pretty simple. It's not too complicated. Okay. All right. So basically, how I was able to develop all this stuff, given the amount of time, we only had a month, and we had all these ideas that we had to get done. So what I like about Python is that it makes the really difficult really easy with a lot less lines of code. So
One of the problems we had is in the national competition, you're not actually allowed to download anything that isn't publicly available for a long time. I think they said it was like a year or so. So like I said, like Li-Wey said, we only had a month to do so. So Python was a great tool, you know, very little lines of code. I mean, if we wrote it in C or something, it would have taken forever. It's not practical. Go ahead.
Oh, and so because we're not able, so some tools we weren't able to use. So Proc Pew Pew I was not able to use at the National Collegiate Cyber Defense Competition, but because Python allows us to create code really quickly, or create something really quickly, I was able to create another version of Proc Pew Pew called Rapid Pew. It's only 18 lines of code compared to Proc Pew Pew, which is 200 lines of code. A lot more simplified, but it's a lot more lightweight, and we were able to get it done.
So what's next? So like since we had limited time to work on these, we'd like to improve the speed and make them more cross-platform. Right now, they're only for like Linux or Windows specifically. Especially with Proc Pew Pew, we want to make that so it'll try and kill those processes even quicker. I mean, sometimes you're able to maybe run one command, but it'll kill any persistence mechanisms at least. We'd also like to add some heuristics kind of knowledge to it. So one of the problems in security field in general now is blue team is always reactive. Like we can put tools in place, you know, that monitor this and monitor that, but nothing's ever like actively looking at stuff and, you know, trying to prevent it before it happens. There are very little things. You know, antivirus, it's always after the fact. You know, by that point, you're screwed. Your data's gone. You know, it sucks. So we want to put some things in there to kind of say, oh, this doesn't look right. You know, in the competition or in life, you know, a typical user would browse, you know, probably start at my home page and maybe click a couple tabs. But if I have, you know, 1,000 requests in a second, that should be flagged. You know, stuff kind of like that. So yeah, so these are a couple classes at DePaul we have that kind of go into stuff like that if anybody's interested. CNS 389 was created last year, and it's kind of based on that competition too. Yep. Anything else? All right.
Any questions?
Yes, I'm kind of confused how red team would use WeyShell. Are you trying to trick blue team into downloading it? Like how
yeah, there's a lot of ways you could go about that if you're a red team. Typically, if you're an attacker, one of the main methods is through the user. So believe it or not, your users are not as smart in technology. So you know, you send them a phishing email saying, who knows what? You have a new Facebook friend, click this link, or you know, your bank account, you just won $1 million, click this link, who knows? So you click the link. It's very easy for either of us to make code that'll automatically down that, run the code, and you won't even know it. And it's just kind of a proof of concept.
What's the stipulation of the competition? Like, how do you simulate that user activity and the web servers that you're trying to protect? They get, like, do the competitors or the judges generate fake activity to those web servers?
Yeah. So in nationals, they'll have what they call an orange team as well. They simulate users, so we actually have a phone, and they'll call and complain if our website gets hacked and they can't do whatever the function is of the website, this and that. There's also bots that generate traffic, so it's kind of hard to notice things. But we do a lot of log watching, other more stuff we write Python for. But we kind of notice, okay, well, I have this weird PHP shell in my web directory. Flag that. We take a look at it. Oh, it's something similar to what Li was talking about. What did you call it? Way shell.
Way shell.
Yeah. Did that kind of answer it? Sorry. Go ahead.
27 DLL and like some of the PYDs. I'm assuming you were using Pi2exe.
I was using CX Freeze. CX Freeze.
Can you talk about when you're building these scripts, what kind of test environment do you set up, like the dev environment? How do you make sure it's air-gapped and doesn't make your daily computing problems? Like when you're doing the dev environment, how do you...
I just use a virtual machine if I'm doing anything critical that will harm my computer. But most of the time, I'm just like, I don't really care. But if there is anything critical, I will, definitely use a virtual machine. That's where everything should be done. Take a snapshot before you're running the tests, just to make sure you get the results you want.
We also have a lab or a lab set up that simulates, like a CCDC environment with web servers and things like that, and that's also air gapped as well.
Good.